So I'm going to give you a summary on my experimental design with emphasis on fire safety and solution contamination and things such as that. So for the first one, for fire safety, going over in the first post video that I made, I went over everything that I needed just in case of a fire. So you saw my room and I showed you that I do have a smoke detector in place. There is a fire extinguisher out in the hallway, and that is my exit to go through there if anything were to catch on fire in this lab. But for other things specific to this lab, I make sure to wear cotton clothing, nothing synthetic, nothing that can like burn up easily. I wore, I made sure that the clay was definitely holding the candle in place, because if it was kind of lopsided or not well done, it could have easily fell over and caught something on fire. But also in that, I made sure there was nothing in the area that could remotely come in contact with the fire. I made sure that the desk was clear so nothing could accidentally hit it or touch it. I made sure the fire and the candle was out of the way, off to the side a little bit, so I wasn't reaching over it trying to reach for my other tools and the other solutions and stuff like that. And then so I made sure everything was good for the fire safety portion. As for the contamination, the solutions come in a little drip container, sort of like a little eye drop thing, so it made it easier in not having it just open and have a giant hole easily contaminated. So to not get it mixed up with each other, I had a loop for each individual solution. So I had 4 loops that I put the solution on, and I just dropped it right on and held it over the flame from there. But it was way easier to not get contaminated if I had everything separate and laid out instead of everything mixed up and messy and just all over the place, and that really helped in preventing contamination. A way to tell if something is contaminated, what I thought is that if you were testing it multiple times, the certain solution in the flame, and if you're getting sort of an outlier, something that doesn't seem right, that's way different from everything else, you can sort of tell that maybe something was contaminated in that sense. But I made sure that nothing crossed over in any way, and that's about it. When I was doing the experiment, I made sure to write everything down in some tables to make sure that I covered everything and remembered it instead of just trying to remember after the fact. So I will go over with you my results that I got from this experiment that we had done. So for the first one that we did, it was lithium chloride, and when I put that in the flame, it took a while for me to notice something. It always just seemed the same, but the more times I did it, and by the end of the 3rd candlestick, I was finally starting to see different colors in each of them. But for the lithium chloride, I got sort of a reddish color, and so when I went to the box to see what wavelength that would be, it's going to be from 650 to 750. And so for the electron configuration for that, it's going to be 1s2 to s1. And the next one is sodium chloride, which when I put in the flame, it came out sort of an orangey yellow color. So I was guessing that the wavelength for that was going to be between 580 and 595. And then the electron configuration for that is going to be 1s2, 2s2, 2p6, 1s1. And then after that was potassium chloride, which came out to be a bluish purple. So I estimated that the wavelength was going to be between 400 and 435. And the electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. And then right after that was calcium chloride, which was kind of an orange color and between 595 and 650 wavelength. And electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s2. So it's just one added electron above from potassium. And that was all my data that I pulled from the experiment. So a self-reflection going over the lab after the fact. I thought this was a pretty easy to understand lab. It was really easy to grasp the concept of it, so I didn't really have trouble in trying to dig further and find deeper information and stuff like that. So the lab procedures gave a lot of information. They were very helpful. They explained it perfectly. They gave you all the background details that you needed before setting you up for the lab. So that was perfect by itself. And then other than that, I used the book to kind of really further understand going from like an excited state to a ground state and how it gives off energy because of that. And then also for last week's class discussion, I picked the choice of doing a hypothesis for this lab. So I already was kind of set up for it because I had already thought about it and kind of looked into it and read about it just to make sure I understood before I wrote it out. And so coming into this lab after that was way easier, already kind of knowing what I was dealing with and what I was expecting to get from the different solutions burning, what colors I had already guessed were going to show in the fire and stuff like that. And then other than that, other than the book and my previous knowledge and the lab procedures, I used this one website called sciencecompany.com because, like I said before, it was really hard to see the different colors in the flames. It took me until the very end of the third candle to actually start seeing colors because I would do it over and over and over and look as hard as I could, and I would kind of see like a faint color every now and again, but I wasn't sure if it was just getting mixed up or if I was just like seeing things or if the flame was just burning weird. So I had to keep going until I made sure I saw like a common pattern of a common color every time that I put a certain solution in. So when I went to sciencecompany.com, it showed me what the certain solutions were supposed to be, what color they were supposed to be. And so it made it easier because when I thought I was seeing red for the first one, I wasn't really sure, and so I kept trying it, but then I looked at this chart and it said yes, it was supposed to be red, so that made it kind of more clear to me that what I was seeing was correct. So for the critical thinking prompts, finding an underlying chemistry principle for both the flame test and the atomic emission spectra, what I found was that what's common for both is the concept of electromagnetic radiation, which is basically just energy in the form of waves. So during this lab, we saw that different solutions, when put into the fire, it gave off a different color. And so reading more into this, it's because the element is in an excited state, and when it moves back down to a ground state, it needs to do something with that energy, so it releases it, and it's releasing it in wavelengths. And so that energy being in wavelengths, it forms a color. And reading further into it, I read that each element sort of has their own fingerprint, their own unique color spectrum that they have individually. And so yes, in this lab we saw that these different solutions gave off different colors, and you kind of just generalize it as, oh, this one's red. But with more high-tech equipment, you can see that there's a certain spectrum of lines, like different colors that each individual element has, that is completely different from all the other elements. So this is what ties together the underlying principle. Electromagnetic radiation goes both for the color spectrum that they give off and for the flame test and testing that to see what color they give off. And then as for the electron configuration, so learning how to do it, you get the periodic table and you understand like there's different sections, the S section, the P section, and then in the middle there's the D section and then the F below. And so I just went along this to do my electron configurations of all the elements that we had here. So just 1s2, 2s2, and then 3s2, and going from there to find every single electron configuration. And that's right, because that's the way we were taught. That's what we know is the certain sections of S and P and D and F.